Hi everyone, here I am continuing on the lesson. Here we have topic 25, which is graphing. So, as I said there in topic 24, so when you have all this information about the function, so from the beginning, so you have all the critical points, and from the beginning when you know what are critical points, and you know where to have increasing, where you have decreasing, where you have maximum, where you have minimum, concave up, concave down, and all of those things, so you can graph the function. So here, in order to show graphing in a very good way, so we can use a cubic function, and cubic functions are a polynomial which is degree 3. Okay, so this function shows the graphing very well. Okay, so but before I start, I have to mention, if you want to really have a very good and accurate graphing, so it's very good that we use a software for graphing, which I always did in the class, and I showed it you on the lesson and those things. Sorry about that. So here is x cube, 4x squared minus 5, and here this is the first derivative. The first derivative is 3x squared plus 8x minus 5, and the second derivative is 6x plus 8. We put first derivative equals 0, we set it equals 0, and find 2 points. 2 points, these 2 points uh, are going to be my maximum and minimum, but I have to check if they are. Okay, so here I can check if the second derivative, so see the second derivative here, the second derivative in 0.52 is positive, so here I have minimum, and second derivative in minus 3.19 is negative, so here I have maximum. Okay, so I check second derivative test and I can answer this question. That's very maximum, very minimum. So first I do first derivative and then second derivative, just for my information, because I have to use it for second derivative test in order to see maximum, minimum. So then I can just write it here. So in this case it is negative, so I have maximum here, right? So I just have to keep in my mind maximum, minimum, and those things. Here I have to find the value for y for each point. Remember, for value for y you have to use f. Sometimes a student, they make mistake, they use f prime, they use f double prime. That's wrong. I want y of the function, and y of the function comes from here, okay? So that's that. And then I know my minimum and maximum point, but here in the lesson, this is part of the lesson, but something is missing. I have to check maximum, minimum test. I have to check second derivative. Okay, so this is my maximum, minimum. So here I can find increasing and decreasing area. So how to find that increasing and decreasing area? What is first derivative? 3x squared plus 8x minus 5. Okay, so f prime is 3x squared, sorry about that, plus 8x minus 5, plus 8x minus 5. And I can find 2 points. So let me see if I can find with factoring. I'm not sure if I can factor here the second derivative. What I'm thinking now. Yes, I cannot factor. I already have the point. So sorry about that, because I was thinking I'm doing I'm doing something else. Okay, so I have two points here, which is one of them is 0.5. Yes, so I used quadratic formula 0.52, and one of them is that, and one of them is minus 3.19. Okay, so I have these 2 points, right? So, and I don't need to waste my time thinking about factoring. Here I was thinking about something else, so it was my bad. So you can use you can use quadratic formula, doesn't matter. Okay, so you have 2 points here. Okay, so one of them is this one of them is this one, and so I have to show here increasing decreasing. Okay, so look at this. F prime x is this. Okay, so one of my point is minus 3.19 and one of the point is 0.52. Okay, in these 2 points the first derivative is 0. How about before and between and after? Before and between and after, it's either positive or negative. There is no other option. Okay, before minus 3.19, I can check minus 3. I check minus 3 here and I see what is the result. Okay, I check 0 here and I see what is the result. When I put 0 here, I see it's minus 5. See, it's 3, 0 squared plus 8, 0 minus 5. It's negative. Okay, so negative. I check 1 here, for example, which is after that. I can teach you a method to say before, after, and between, but I don't want to go to those details. So I tell you, test the point. Okay, so you can check with a point. But remember, the point must be for sure after, between, and before. And sometimes students make mistake here. Okay, so 1 is a good point, so I can check. So 3 plus 8, 3 plus 8 minus 5 is positive. And here if I check f prime at 3 is also positive. So I can say it's increasing, decreasing, increasing. See, it's going up. So here I have maximum and it's coming down. Here I have minimum. Even you can answer maximum, minimum on this table as well. And I used to do that. But the second derivative test is easier because you find the second derivative and check if second derivative at a point is positive, minimum. If negative, maximum. Okay, so you have this, and then you can say, look at this. You can say from minus infinity to minus 3.919, and here it's union, so like or in English. Okay, so or from 0.52 to infinity is increasing. From minus 3.19 to 0.52 is decreasing. Okay, so if I want to review, what I did was I have the function, I find first derivative first, I find second derivative next, I find first derivative roots of first derivative. So where first derivative is 0, these are my critical points. These are my critical points. Critical points happens here. Okay, and then maybe I can change the color. It's just to connect them together, so I can do this. Critical points are here. Okay, I can find them, and then I can check second derivative in those points, and then I can say which one maximum, which one minimum. Okay, and then I have those points, and then I can say where is increasing, decreasing. How? I have to check where the first derivative is positive, negative, positive or negative. Remember, first derivative. First derivative is related to increasing, decreasing. Okay? And then I can answer this. So I can check where is 0, so other than 0 I have minus and plus. So I can check. So here I have plus and here I have minus. Okay? Sorry, here I have plus as well. So in between I have minus. And then I know from minus infinity to minus 3.19 and 0.52 to infinity is increasing, and in the between 2 points it's decreasing. Nice. Okay, so I can check that. This is helping me in order to graph my function, because I know I have to start from where, I have to go to where, so I can see. Also, I can find inflection point. Inflection point gives me the ability to do concave up or concave down. Okay, for inflection point, I do second derivative. Second derivative equals 0. This is the point. This is y. Remember, for y you go to f, not f prime, not f double prime. This is inflection point, but I'm not sure. I'm thinking it's inflection point. Again, something is missing here. I have to check if double prime changes the sign. Okay, so I have to check here. Okay, so I have f double prime, which is 6x plus 8. Of course, because it's just first derivative, because it's first degree. I think it's morning, I didn't wake up. Okay, so because it's first degree and I have minus 1.3, just 1 point. Okay, of course, before that is before that I check minus 2, and after that I check 0. Okay, after that is positive, before that is negative. So it's concave down and concave up. Because it's just first degree, of course it's 0 in 1 point and it's negative positive before and after, of course, but I have to still check it. Okay, so this is inflection point because second derivative is 0, but I see also second derivative changes the sign at this point, so from minus to plus, so from concave up to concave down. So I know concave down is like that and concave up is like that. Okay, so I can know all of these things and graph my function. Intercept is also very important, because I can see where do I touch x-axis, where do I touch y-axis. How do you find x-intercept? How do you find y-intercept? Okay, for x-intercept you put y equals 0 and find those points. Because you have degree 3, you have 3 points. There is a theorem in math that says if you have degree n, you have maximum n roots. Means maybe n roots, maybe n minus 1. So here 3 roots or 2 or 1 or 0, but you have 3 here. Okay, so it's possibility to have maximum 3 roots, and you do have here. Okay, so these are the points here. So 0, 0, minus 5 and 0, and 1 and 0. Then I can graph it. So it is x cubed minus plus 8x, so plus 4x squared. Let me see, minus 5x, something like that. Yeah, plus 8 plus 4x squared minus 5x. Yeah, minus 5x. Okay, so I know if I substitute almost minus infinity, if I go to minus infinity, it is minus infinity. So I have to start from down. Okay, after I have to start from down, then I have to reach to this point. First I have to reach to this point. Okay, so I have to start from minus infinity, then I have to reach to this point. Then I have to reach to maximum point, which is minus 3.19. What was the point? Minus 3.19 and something. 24.19. Okay, 24.19. Then again I come down. Okay, so I come down to 0 and 0. Then again I go down and down to minus 0.52, and which is the minimum, minus 0.52 and minus 3, so minus 1.38. Okay, I go down to that, right? So I can start from here, I go to maximum. Okay, I go to maximum, so I go to y-intercept, and then I go to maximum, and then I come to this, and then I come to this. So I can see all of them here. Okay, and then again I go to 1 and 0. Again I go down, I go up, again I go up, and at the end I go to infinity, because when I substitute infinity, I can see when I substitute infinity here, I see it goes to infinity. Okay, so I know I have to start from this minus infinity down. I have to reach to the first y-intercept. Okay, I'm sorry, to the first x-intercept, and then I have to reach to x-intercept, and then I have to reach to maximum, and then I have to reach to second x-intercept, and then I have to reach to minimum, and then I have to reach to third x-intercept, and then I have to go to that. Okay, this gives me a good picture. Okay, and also it's a very good idea to have picture of the graph in your head, because I know when I have second degree I have parabola. Okay, it's parabola like this or like this. When I have um, power 3 I have something like that. Okay, so I can now do it. Okay, so see here I can do it here. So for example, let me see here, I have to go to okay, so I have to have to 24, and I have to go to a very small number, so that, so maybe it's good idea that I do this. Okay, so I'm not sure if I can go 3 by 3, so 1 2 3 4 5 6 7 8. Yes, so here I can say, okay, for example, I am in the middle, then I can say here is 24, and then I can say here is minus 3. Okay, and here I can do let me see, minus 5, so I can do 1 2 3 4 5, so I can do here minus 5, and then I do 0, and then I do 1, 1 and 0. Okay, yeah, so 1. So then I can graph it. So I can say, okay, so I start from up. So then where is my maximum? Okay, so my maximum is almost, let me see, 3 here and 319, and so it's almost here. Okay, it's almost here. See, I know I start from down, I reach to this, I go up to this, then I come down to this, and then where is my minimum? So my minimum is somewhere here in the middle. Okay, so in the middle here and here. Okay, so I reach to this, and then again I go up and I do this. Okay, so by just looking at all these behaviors of the function you can graph it. But again, I would say the best way to graph is using a graphing software, because they can show you a very beautiful graph. Okay, but here you can have good understanding. So how? By finding the first derivative, finding the second derivative, finding critical points, check second derivative to see which one minimum, which one maximum, then check increasing and decreasing by first derivative sign, the table, positive, negative, checkpoints. Then you can find second derivative root and find if it is inflection point. Okay, so and then you can find intercept, x-intercept, y-intercept, because they give you where you have to touch x-axis and y-axis. Okay, and this one is x-intercept and y-intercept at the same time, because 0 and 0. Okay, and then you know from where to start and where to go. But again, it's a very good thing to have a good picture in your head, so at least I know, for example, e power x, how e power x look like. Okay, so it's good to have a good picture in your head. uh, Otherwise it will be hard. You need a lot of information. You need to have to consider maybe asymptote, maybe what is the behavior of the function when x goes to this point or that point, and many things. So you don't see those functions in the college. Okay, so here everything is smooth. Okay, so and this is the graph, so I did it with a software that's more beautiful to see. Okay, and here I'm doing it. So here I just do, so for this one, for x-axis I go one by one, one by one, and for y-axis I go 3 by 3, because I don't have room there. I have to go reach to 24. Okay, so you can practice on this. You can do the same thing for this one. You can do all the practice for this one, and then look at the graph here. Okay, see, look, you again you start from down, you reach to x-intercept, you reach to maximum, you reach to another x-intercept, you reach to minimum, and then you reach to another x-intercept, and then you reach to infinity. Okay, you can have this in your head, and then picture and find it. Okay, find the graph, do the graph. Okay, hopefully this was helpful. So now I go to the lesson here. Okay, so motion of a point. I talked about this before, and also I want to mention again here. Okay, so if I have a function which is, for example, if I have a function which gives me the motion of a point or motion of something, okay, so for example like s or ft, if I find the first derivative, I can have the first derivative and say this is velocity or speed. If I have the second derivative, I can say this is acceleration. Okay, so you use these in physics. Okay, we don't talk about physics just part, but in math part, it's just derivative and it's very easy. This was one of the questions in the final exam, so they are not hard questions, so you can do them. Okay, so then in future when we teach you integral, so we give you, for example, we give you this acceleration and we want you to find this because it's antiderivative and you go backward, and then you go backward to this one. Okay, so this one, but here is much easier because we know how to find derivative. Okay, so here it's s prime t. Okay, I have st, this is the motion of the function, means something is starting from minus 3.3 point meter. That means I have an origin, I have a 0, so which is my original point or origin, and then something is starting from minus 3.3, and then going forward, just using this function. So for example, if t is 0 second, it's standing in minus 3.3 meter. But if I have t equal 1 second, so it's changing because I have to substitute 1 here. Okay, so after 1 second, no. So here let me show you. So here you have s0 is minus 3.3 meter. This is at the beginning, but after 1 second, what happened? Is it second? Yes. And the question tells you second or minute or hour, meter or kilometer. S1 is 3.4 plus 5.2 minus 3.3. Okay, and you can find this is in meter, so this is 5.3 meter. Okay, you can find the answer. So let me check with my if I have the, if I, yes, I have the calculator here, and I'm thinking I'm right, but um just because it's early morning, maybe I make mistake. Okay, so no, I'm right. Okay, so after 1 second, it's 5.3 meters. So you can find the displacement and you can find the just where and how many meters the motion is happening. Okay, after several seconds, and then I tell you, okay, so find the displacement at this point. So you can say, okay, if displacement at this point is s 4.30, means you have to substitute s, you have to substitute t equal 4.3 in there. Okay, so let me do it. It is 3.4, 4.3 cubed plus 5.2, 4.3 squared minus 3.3 meter. Okay, and you have to find the answer. And then I said velocity. What do you do for velocity? Easy. For velocity, you just do first derivative. Okay, find first derivative first and then do substitution. First derivative is 3.34, 3 multiple 34. Okay, it's 10.2 t squared plus 10.4 t done. This is s prime. This is the velocity, function for velocity. And how about for, so velocity, okay? And how about for acceleration? Okay, for acceleration, you do double prime. You do the second derivative. So 20.4 t plus 10.4, right? So done. Then what is the answer? The answer is substitution. You have to substitute 4.3 and find the answer. You have to substitute 4.3 here and find the answer. Let me find the answer for the other one. 3.4 times 4.3 cubed plus 5.2 times 4.3 squared minus 3.3, which is 363. So it is 363.17 meter. And here I have to round to two significant digits. So I would say 360. Okay, so remember, you have to substitute, you have to check how to round and all of those things. Okay, so here how you are rounding, you have to see here you have two significant digit, you have two significant digit, you have two significant digit, you have to round to two significant digit. Then you have to see when you round to two significant digit how many decimal place you have, and then how many decimal place of the other one, and how many decimal place of the other one. But because this one has one, so I go to one. Okay, so these are just has to be done in the question if I say all numbers are approximate. And if not, you can just round based on the question, just the way that we ask for. Okay, so here, so this is the so the displacement. Okay, this many meter. And how about the S prime? So S prime at 4.3 is 10.2, 10.2, 4.3 squared plus 10.4, 4.3. And when you find the answer is meter per second. Remember, these questions are not hard, but very important that you include the unit. How about for acceleration? For acceleration, the unit is meter per second squared. You can just substitute, find the answer. At the end, you have to add a conclusion sentence, you have to add a statement, you have to show you understand the question. And you always know it's very important for us that you show you understand the question. You have to include the unit. Meter per second squared is acceleration. And how do I find it? I just substitute. And how do I find acceleration and speed? By just derivative. Very easy. Okay, so here, this question is very nice. It's a very nice question because it's giving you just some tricky points, and they want you to think about it and just answer. So here the motion is that. Okay, so here this is the motion, and we want to find the velocity. Okay, so how do I find the velocity? The velocity is S prime, so it's 6t squared minus 42t plus 60. And what is S prime at 3 and what is S prime at 6? I can substitute and find the answer. Okay, but didn't say, let me see, it didn't say anything about yes, second, yes, but it didn't say anything about meter or. So here I have to say unit per second, and here is unit per second squared. Why unit? Because I don't know unit of the motion, so maybe meter. It didn't say in the question. Okay, and the note, the answers are not with me to say. Okay, so it says when the particle is at rest. So what do you think here? So we have to just here we have to think about it, you know. So when it's in rest, so we can answer that. Okay, the particle is at rest when the speed is 0. It's not moving, right? So the speed is 0. So I have to find where the speed is 0. So I have to see 6t squared minus 42t plus 60 equals 0. And I factor 6. It's t squared plus minus 7t plus 10 equals 0. Can I factor here? I think yes. Here is 6 times t minus 2 times t minus 5 equals 0. And t is 2 seconds and t is 5 seconds. So at these two moments, the particle is at rest. It's not moving. So you have to understand what does this mean then. Okay? For these questions, so we have to have a good understanding of motion, Okay, so you can find the answer here. So it says when the particle is 2 seconds and that, and make sure to include the unit, and make sure to have all those information. Okay, so I'm going to finish now. Here, and I am going to continue after. Let me see, this is one question, and so that's Wiley plus question that I want to mention, and here, and also, okay, so these are just practice question. Okay, so for practice question, mm, we didn't do them before, but I'm going to some of them we skipped before, some of them we did, but I think I'm going to do them now that I'm teaching you online, so I try my best to do them. Okay, so right now I am going to stop now here, and so I'm going to continue after. Thank you so much. Bye.